for the time your friends are joining, uh, can you tell me if anyone of you gave yesterday's contest? Like, if you gave it, then how many were you able to solve in the contest? Preetham, Alicia, anyone of you?
Yes, I gave it. I solved three problems.
So you did A, B, C, right, or A, B, D.
I solved A, B, and C.
So means, are you consistent with the contest? Are you giving it regularly?
Yes, yes, most of the time. Like in vacation, I gave all the contests.
So means still now on all platforms, right? At Coder,
No,
Code
I
Chef.
basically give in Codeforces and AdCoders regularly, but I started CodeChef. I gave two or three contests in CodeChef.
Okay, and what about you, Alicia?
I gave last contest in Codeforces and solved first and second problem only.
So this contest, right? Yesterday's.
Yes, yes.
Good, good. You all are doing good. For the vacations, have your main focus over contests, right? So it will help you later on. So we will be discussing today uh, Codeforces round 1102 div 2, right? So both of you said you were able to solve two or three. So I guess the first two won't be a problem discussing. Still, let's start with the first question. So I guess both of you had read the question right. Let
Yes.
me read it out for you till then. So it's like we define a allocate algorithm of sequence of length k greater than 2 for two positive integer x and y. So we are given a1, a2 and all. And as we know, a1 is equal to x, a2 is equal to y. We need to see if a sequence exists, means a permutation of our given sequence exists, such that it's every third uh, third term is the first term mod of second term, right? So what was your approach? I will also share mine. Before that, both of you just tell me what you guys did.
So I did was that first sorted the whole list in descending order, then checked what the third number is equal to mod of previous two or not. If it is, then return true.
And what about you, Alisha?
Same approach.
So why were you doing this decreasing order? Means you said no descending or non-increasing, right? Why did you do that? What intuited you to do that particular thing?
It is because when I take the mode of AI and AI plus 1, the remainder would always be less than those two elements. So I sorted it in descending order first and then checked for each. And when it is not equal, then I'll break the loop and see out not -1.
Yes, good. Also, Preetham and Alisha, I guess you both guys did the same thing. Looking at the constraints, you'll see the constraints at T is 500 and N is 100. So did you guys get any hint at can we do a brute force for the whole thing? Like we check all the combinations possible and just see out if it's possible or not. Did you think in that way?
If we brute force, then the possibilities of combination will be n factorial, so it would give time limit exceeded.
Actually, the possibilities won't be n factorial. As C, we always choose the first A and B amongst the whole sequence, right? So we are only picking two values, A and B, from the sequence. and then we kind of try to form an array with that sequence. Are you getting it? What I'm saying? So we are not getting n factorial. We are not taking the whole permutation sequences. So we are only taking when to form one sequence, right? So what I meant was, as n is 100, we can use a n cube log n approach, right? I understand your answer is optimal, but if we want to go brute force, then we can use this too. Okay. So what we do, as we know that what we want to do is like form an array with C, C being A percent B, that is A mod B, and A is the maximum of the value means in that array, and B is the second maximum or the minimum, you can say, right? Then we try forming the sequence in such a way that A and B are the first two values, as we have got here mentioned, that X and Y. We are just using A and B instead of X and Y here. And X and Y are the first two values in the sequence, right? So we are only choosing A and B, which is n square. Okay. Then we form the array and check if it's equal to the original one. That is, we are trying to form all kinds of array by choosing first two integers, and then we are checking if that's equal to the original one in any permutation. How can we check it? Are you able to get why it's not n factorial and it's just n square to get all possible?
Yes, I got it. Got it.
I hope you also got it, Alisha. If you guys have any doubt, just uh, raise your hand or tell me in the comments. Okay. So what are we are doing first? First, we take in the whole array, and then we sort it. Why we are sorting it? Look, this is a very brute force approach, right? So we are sorting it to later check on if the whole array is same or not, right? So what do we do for the whole array in n square? We take two values a, b. A, b are the maximum and minimum. A is the maximum among vi and vj. That is, we are having two values, and we are check means taking a as maximum and b as minimum amongst them. And then we are taking another vector v1 and pushing all our values, means first ab, and then keep checking for this. What do we say? We push back the third element as first element mod second element and keep on repeating this. I think you guys solved the question by yourself, so you would know what does this statement mean. Anyone? Right. So it is for if v1 of k1, that is, if this value, that is the second value, is, what do we say, it's 0, then it will cause a runtime error, right? So we need to have a check beforehand. That's the only thing required. And if there exists, then we see out A and B. Else we can at the end return a -1. And you guys already guessed the optimal way. We can say that A is greater than equal to B and C is A mod B, right? So C is less than B. Similarly, as B is less than A, so C must be less than B equal to A. So this, to check if the whole array goes right, we need to only sort the order in a non-decreasing, means non-increasing sequence or decreasing sequence. And for each, we need to keep a check the vector of, means position of that array at third index is, means first index mod second index, right? And we also need to check vi is greater than 0, as we cannot have vi, means vi plus 1, that is the second value which we are taking the mod from, to be non-negative, means non-zero, right? So I hope everyone is clear with the problem. I don't think I need to run the test cases out here. If you have no doubts, I will proceed to the second question. Just give me a thumbs up. So both of you again did the second question, right? The second question question was a very math intuitive problem. This palindrome 12 and 2 terms, right? So, what was your approach? Let me read out the question till the time being. So, we are given an integer n. N is in 10 to the power 18, and for key test cases, so we need to return a palindrome number, and b, a multiple of 12 such that a plus b is equal to n, right? And if it's not possible, then we return -1. So what was your intuition?
At first, I I run the loop from I is equals to 1 to I is equals to 0 to some around 1 lakh, and check in each condition if n minus 12 into I is palindrome or not. If yes, then output at x and y. It was actually a brute force approach. It ran in second, third out inputs, and for last two, this failed. So I further made an approach. If x plus y is equals to n, then taking modulo on both sides, x modulo would be equal to n modulo. So first I started taking small palindromes of x and modulo with 12. So it will give from 0 to 1 to 12. So for each case, uh, I'm not able to explain actually, but second one run when opticon big of one time complexity. Can I say in Hindi? Hello?
Yeah, you can go on. It's not a problem. You can just explain or leave it in the middle also, and you can use Hindi too.
So x का modulo with 12 will be equal to n का modulo with 12. So rather than checking in a loop, I just uh, tried to
Alisha,
take
Alisha, you
little.
can be comfortable in Hindi. It's not a problem. मुझे भी हिंदी आता है.
अच्छा, तो मैं छोटे छोटे पैलेंड्रोम्स को वन बाय वन चेक की इसका 12 के साथ मॉड्यूलो लेकर के, एंड जस्ट सिंपल केसेस आई गॉट द आंसर कि जब भी x का मॉड्यूलो 12 के साथ अगर 10 नहीं होगा, इसके अलावा सारे आंसर्स x सिंगल डिजिट्स में आ सकता है. अदरवाइज अगर मॉड्यूलो 10 है तो x इक्वल टू 22 एंड फर्दर से आंसर आ गया. I'm sorry, Vai, I'm not able to explain it clearly.
No, I understood mostly the logic. So, Preetam, can you guess means what she missed? Only one point she missed. Mostly she has explained all of it, right? So, Preetam, just tell me what she missed. Only a single thing.
So she initially told that she checked for every possible BB which is multiple of 12 and checked for n minus b equal to palindrome or not. So it might give a time limit exceeded error. So
it actually it won't give a time limit exceeded error, but it can rather give you non so useless means not so good values. She was first checking in a range from 1 to 10 to the power 5, right? And then she was seeing if a I and means if a I is palindromic, and then if n minus I is a multiple of 2, right, Alisha?
Yes.
So after that, what she said was, it was the actual approach. So can you guess what was the problem with that approach, Pritam? Means she mentioned all of it. Let me tell you what she mentioned. Then you can tell me only one point that she missed. Right. So she told, like we have n, we take modulo of it with 12. right? So we get some values A, we are getting A, and we are getting something like 0. A is the remainder we are considering here. And she said, like, she checked all those remainders. This can lie in between 0 to 11, right? She said only 10 is not palindromic. So means 0 is palindrome in itself, 1 is also, 2 is also. Everything is palindrome except 10. And the other one, that is B, will always be a multiple of 12. Then she said that, then she said that for if the mod is 10 and the number we see out n as 22 and uh, n minus 22, right? So what was she missing? Only one point she missed. Pritam?
Because all the other numbers will be palindrome for A. Well, means if it is 0 to 9, it will be always a palindrome. It is 11, then it is also a palindrome.
Yeah, it's right. But she was only missing that n must be greater than 22. If n mod 12 is 10. So she was missing only that in her explanation. Else it was fine for both of you. I guess, Preetam, yours approach is also correct, right? It's the
Yes,
same.
yes, I have done the same thing.
Yeah. So let's see how we can prove it mathematically, as it's a straightforward maths question, right? So what do we do? First, let's look. N is equal to A plus B, right? Let us consider B is equal to 12k. Let k be a natural number. We know B is a multiple of 12, right? So n is equal to A plus 12k. So taking mod of 12 on both the sides, it's A mod 12 and plus 0. So we are not given that we have to increase the palindrome's length or something. Then it would have become a very huge question actually. Or else we are just given n%, means n mod 12 is equal to A mod 12. So if we get any A that is less than 12 and is palindrome, we can always satisfy this, right? By taking n modulo 12, whatever palindrome we can get, we can place it instead of A. And this is our basic first intuition. So what are the remainders of n modulo 12? 0 to 9, and then 10 and 11, out of which, except 10, all are palindrome in itself, isn't it? Right? So, so our answer would have been n modulo 12 is equal to 10. If it is true, then it would be -1. That is, we can never get our answer. And if not, then n% 12, what it can result in is 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9, and then 11. And then we deduct the whole number from n, right? I guess you understood what I said. So checking our logic with the sample test cases, we saw 1 get 1 comma 0, right? This is 1 is the remainder and 0 is the multiple of 12. For 10, it's already modulo of 10, it should be -1. For 310, it also should be -1, as 310 out of which, like, 300 is divisible by 12, right? It's divisible by 12, so we should also get -1. But, and then again, these are just the basic run loops. But in the original answer for 310, we do not have a -1. So in the sample test case, so we need to think. So let A be 10 for only 10th. When remainder is 10, we are missing the test case, right? So let us think more on our intuition. So let A is equal to 10 plus 12t. Let t be the smallest number, means let t be a value, integer value, that we add to A, multiple of 12, so that A becomes a palindrome. So for t is equal to 0, A is 10. For t is equal to 1, 12. It's a palindrome, right? So we don't need to go on any further. And we check if the remainder is 10 and the number itself is greater than 2, right? Means 22, then we always have an answer. But we only don't have an answer when n is equal to 10, right? This is the same as our sample test case, and we can have it prove that we never have answer for this. We already have our proof. Alisha, I think you got clear with your approach, and Preetham also, you are already clear with what I said.
Yes, please.
So right, so we only check that n modulo 12 is equal to 10, and n is less than 22, or we can just check n is equal to 10 and see out -1, or else we always have an answer that n modulo 12 is 10, and it will be 22 and n minus 22, right? Or else if it's means if it's any other modulo, then it will be n modulo 12 and maximum. I have just taken it in my code. You can't, it's not necessary in general. You can take n minus n modulo 12, right? If you guys have any doubts, you can still ask me. Okay. I hope the approach was pretty easy if you just entered at the max. So any doubts? If so, I guess Alicia, you were not able to do this problem, and Pritham, you did this problem, right? See, did you read it, Alicia, while trying to solve it? And Pritham, what was your approach for the question? Means, I'm not talking about the question approach, but just tell me what you understood from the question statement itself. The question statement is also very, actually, it's confusing, right?
Yes, so I actually did was that for each of the vessels, I checked for the maximum height of each other vessels for clockwise direction and also for anti-clockwise direction. So means if I go in clockwise direction, to then I will store the what to say maximum value of a vessel or the maximum height it can, such that sorry I cannot able to understand you. So means if I go in clockwise direction, so for each other vessel
Don't worry, just explain slowly. First, tell me what you understood from the question. Like, what did the question ask? This H1, H2, and W1, W2, right? And then just tell me in short.
so question asked was that uh, for each of the vessels that were given, we have to answer we have to answer that for all the vessels, such that for every ith traversal, that ith vessel should be empty. So, and for that, what should be the maximum height we can gain for the other vessels?
Yes, above the other vessels, right? So I guess you are somewhat clear with the question. It's just that uh, you cannot explain it in words because the question itself is very visual. And Alicia, did you read out the question during the contest?
I actually did not read this question. Just move to the next question.
Okay, so first let's discuss this C, then we'll move on to D, right? Then Preetham, just if you have any doubt while I'm explaining, or if you also agree with the approach I'm talking about, just give me a thumbs up, right? So let me read out the question. This is the easy version. Don't consider it. Main question starts from here. So you are given an array of heights h1, h2 till hn, a cyclic array of non-negative integers w1, w2, wn is called good if the following holds for every I from 1 to n, maximum of two adjacent weights if it's greater than the height of that tower, whatever you can say, then the adjacent weight will be equal to the previous one. That is, they both will decrease to the lower amongst them, right? That is, if the maximum of two neighboring element of the array exceeds the corresponding element of the array H, then these two neighboring elements of the array W must be equal. So what do we mean? We have an H1 array, kind of. It's representing some height of some cube. You can imagine like this. And it's also said it's a cyclic array. Okay. So we have W1, W2 be the water in the vessel for array, which the following are satisfied. And it all goes in a cycle, right? So cycle means that for Hn, we get H1 after that. So what it's trying to say is that for given condition, at this point, we have got this height. You can see, you can look at this tower, this, and you are saying that if the water here at this point and the water here are greater than this, then water means if there is water here, we mean to say is, and there is water here. So look, it overflows to this place or it overflows to this place and it henceforth overflows to another vessel. So it's kind of just telling us that it's obeying just basic physics to be held between two towers and it's cyclic, right? So what we are talking about the towers having here is the same as tower being here. So what we are given as the first sample test case, 4, 1, 2, 3, 4, right? Let's imagine the setup with this. So we have given 4 towers. This is tower 1. This is tower 2. This is tower 3. This is tower 4. This is not the fifth tower. This is again the first tower, right? This is again the first tower. And this is again the second tower. Okay. So we are just having it record. Okay, so it's again the first and second tower. You guys understood the cyclic meaning of the towers, I think. Okay. So then what we are asking that for the ith vessel means for this tower that the first, let's consider the ith tower to be first. We don't want this water here to overflow from this place to this. Think if we have another water here, this thing is water, we are considering it water, right? If we have this, it will overflow to this place, but this will overflow again to the previous one. So it's not a possible case, right? So what do we want to say is between two towers, that is first and second tower, we want to maximize the water that can be stored between them. For second and third tower, we want to maximize the water that can be stored between them. And for third and fourth, we want to maximize the water that can be stored between them. Means 3 and 4, right? And this is for the ith, means the first vessel over the first vessel. So for this, we need to cyclic rotate the whole array. Like it goes like this. So again, we start from this point. First, we're starting from here till here, right? Then we go on from this till this. And we check for over this array. And then we check over this. It's like a cyclic shift. We check for all ith ones, right? I hope you all understood what I was saying. If you guys have any problem, you can ask in between. So we're just imagining, means we are just visualizing kind of empty vessels between the towers of height 1. There's empty vessel here, then tower 2, there is empty vessel after that, and tower 3, there's empty vessel here. So we want to hold the maximum weights in these vessels, right? Except the vessel we are talking about. So if look, this is what exists beyond, means before this one. It's the same thing, right? So we want to only fill up these vessels. This vessel, then again this vessel, then again this vessel, this one. So we want to fill up this, and this, and maximize the water. So how can we maximize it? So I've already explained you there are in vessels and all. So it falls back to left, or else it falls back to the next. That is, it overflows to the both. Right. So we need to have kind of minimum between both the towers. So we see the test case is just 1000 and n is also 300. Also, it's an easy version of the problem. So you can easily see that we can get the idea of O of n square. Right. So have you heard of the classical rainwater trapping problem, which introduces us to monotonic stack? Although I haven't used monotonic stack here for better understanding. So have you guys heard of the question?
Yes, I have done it on lead code.
And that's why you were able to understand what was going on here, right, Pritam?
Yes, yes.
So it's just the classical rainwater problems, a little bit modified version, that we are having zero height columns in between two towers. Isn't it the same?
Yeah.
And what about you, Alisha? Did you understand the question now?
Yes.
So, as we can see, to trap the maximum water over a vessel between two towers, the vessel to the left we want the maximum height as much as possible, and also to the right we want to have the maximum height. So the vessel's own height is negligible, you already know. So we can trap as much as water, and it's already given here. The base is 1 centimeter square. Also, it's not a very big thing to see. So the base is 1 centimeter square. So the height is the net volume at the end. Okay. So we need to take the cyclic shifted for each. So we need to have new array, means new vector for each cyclic shifts. So for test case 1, what we were seeing, we look at the test case here. So you see what I am meaning. This was the rough work I did during my contest. So the rough. So this was the first question's rough. Then there was the second. Right. So then we go on. This is what I am meaning. This is the empty vessels we have. This is the tower. Okay. So for this vessel, we want to store waters between these tower, and between these towers, right? So for our first test case, for this vessel, if we want to store water between the tower of height 1, tower of height 2, then 3, then 4, for this vessel, then we can store water in between here, right? So it will be of height 1 and 2, minimum of that is 1. So it will be water of height that. Again, between 2, it will be water of height 2. And between 3 and 4, it will be a height of 3. So 3. So total water we have trapped is 6, right? So total water is 0, 1, 2, 3, and 6. The total is 6, right? Then we cyclic shift it. That is, this is the height 2, this is the height 3, this is the height 4, and this is the height 5, right? So we need to trap in between them. So let's have the maximum level marked. Okay. So this is the height. We can trap 2 water here. We can trap 3 water here. And again, what we can trap is one water there. So it is again 6. Now look for if we shift it once more. That is, think of a case when we have towers. This is the tower. This is the tower. And then there is the smallest tower of height 1. And then there is the middle tower of height 2. Right. For this height is 1. For this height is 2. For this height is 3. For this height is 4. Pritham, I guess you already answered the question. So I will ask for both of you, what is the maximum height that can be achieved between two towers? Alisha, what can be the maximum height achieved between 3 and 4 tower?
It would be 3.
Right, it will be 3. Pritham, between 4 and 1, what can be the maximum height achieved?
It will be 1.
No, it will be 2. Look, we have a bigger
Oh,
2 here. You see,
oh,
we
I
have a
didn't see
bigger
that.
2 here. Yeah, so I guess the screen is visible, right?
Yes, yes.
Yeah. So we can always store 2 here. We don't need to store 1. We can store 2. And between 1 and 2, again, what we can store, Pritam?
It's 2.
Right. So it's 3, 2, 2. So the total is 7. So similarly, you can see I have written here. So what we are doing for this one, on the left, we are checking what is the highest tower height. So we can always get the highest, means maximum possible. Okay, so for this tower, let's consider an example. The highest tower is this. So we always take this tower as our left, means right reference, so that we can get highest, not these two. Right? Pritam? Okay. So you can see then, means we are just checking the leftmost maximum and the rightmost maximum for this vessel. Okay. And then we finally get our answer for both. So you see what we are doing in any random, let us consider a random example. That is, we have a tower here. Then this is something. Right. So let us keep it 7. Let this be 4. Let this again be 4. This is 3. This is 2. And again it's 3. So just tell me, Pritam, what will be the height, maximum height between these two towers?
It will be 4.
Yeah, right. Uh, Now I think you remember what you did in the question. And what will be the height between these two towers, Alisha?
It would be 4 again.
Yeah, right. And again, for these two, means all of them, it will be the height 4. So I guess we got our crux. So for the ith, we are checking for the left maximum tower and the right maximum tower. And once we get our left maximum and right maximum, we just take the minimum among them. Right. We are just taking the minimum among them. So I guess you understood the logic. So how to do it in code? So this is what I meant. So this is the basic rainwater problem figure. I guess you guys already seen it everywhere. So how can we do it? We can use two maximum arrays. So one maximum array will be a maximum prefix array, so that we can get a left maximum. For the ith one, the left maximum will always be the prefix max for this. If there exists a maximum to its left, then it always have a value greater than this, right? I think you understood the logic behind left maximum. Means prefix max, and for suffix max means for the right maximum we are using a suffix max. So let us consider what I was meaning. So this is our example, right? So let us define two maximums. For 43724, what will be the maximum array? The maximum array will be, if we go from left, that is prefix array. It will be 4, then again 4, then it will be 7, then again it will be 7, then again it will be 7, and again it will be 7, right? And if we go this way, then it will be 4, 4, 4, 7, 7, 7. So for this ith, for this tower, we are checking to the left what is the maximum. To the left, the maximum is already 4. And to the right, we don't check from here. We check from this place. As we don't want to include that tower in particular, we check for this part. So what is the maximum? Between 4 and 7 means this is the 4 that is left maximum and 7 is the right maximum. So what is the minimum between 4 and 7? It's 4, right? And for these two, it's again 4. For these two, it's again 4. So yeah, we already see how we can get our answer. So let's see what was the case. So for 1, 2, 3, 4, the left maximum goes like this is the suffix. That is, this is the prefix, right? And this is the suffix. It goes like this. So what is the maximum between them? So minimum between them, it's 1. The minimum between them is 2. And the minimum between them is 3. And we have our total sum 6. Look, we can do it in O of n2, searching for each ith value, but we need to save time. That's why we are taking O of n space, auxiliary space 2 n. That is, we are taking suffix and prefix, so we can just fast the calculation, right? We can only go up to O of n, because always remember that we don't only need to check for one orientation. We need to check for all n cyclic orientations, right? Preetham and Alisha, I hope you got the logic now. So yeah, it's a O of n square problem then. As for all of n, we are just checking all cyclic shifts in I, right? For one n, we are checking the cyclic shifts, and then in another n, we are calculating the prefix sum. And for that particular cyclic shift, we are just doing the same. Okay. So, right. So this is auxiliary space. We are taking 3 of n. First, we are having it's a temporary cyclic shifted array on which will perform our left max prefix and suffix operation. So after that, we have just made a maximum suffix array using these lines and a maximum prefix array using these lines, right? And then for the sum, we check if minimum of E of j and S of j plus 1. Why we are doing S of j plus 1? Because remember that S of j plus 1 we are doing because we need to check for, think if we are checking for this vessel. If we want to have the left maximum, this will be the left maximum. But the right maximum will be at position I plus 1, right? So we are doing a suffix of I plus 1. So this is the basic code. I think you all are clear with it, as the test cases were just 3000. We can go for O of n square and the 3n auxiliary space too. Right. If you guys have any doubt till now, just ask. Or else we'll move to the last problem of today's TCD. If you don't have any more doubts related to C, then you can give me a thumbs up. So both of you guys did read this question during the contest, right? Preetham and Alisha.
Oh, I read it, but I could not evaluate. Means time was constant for me. For it. Time
Uh,
ended.
okay, it's not a big problem. So what you understood from the question itself means I guess you have time. Means you had the time to read the question, so you understood something from it in general.
Actually, I could not understand it properly.
Yes,
I read it only once or twice. Only read it, so I could not understand it.
okay. So yeah, the question seemed a little bit confusing, but it's okay. It's not a very big problem. So right. So what we have given n. N is in 10 to the power 5. Let's simplify the question as much as we can. Instead of reading this from here, you can read it by yourself. I will tell you what the question actually means. So we have two numbers, A and B, in their binary format. So look, we are taking the binary format string. Okay. So we have string with n bits. This is the n. We are also given k, and k can be till 30. We need to form a sequence of length 2k plus 1. So what 2k plus 1 means? That we have to form a odd length sequence, right? 2k plus 1 is what? It's just a odd number. It's simply a sequence. You don't have to worry much about it. And we are just taking 2k plus 1 such that we always get a center point, right? We are never confused in between if you are getting 2 points. Okay. So for any empty cells between the extreme filled, so let us consider these are the filled cell. We have taken already 2 to the power k plus 1. Alisha, you also read the question, right?
Yes,
So did you understand it?
I understood the problem, but not able to implement any codes.
So you had any approach?
Not such an approach, but I tried. Like first taking the zore of. Actually, I tried it today. Not that much good. I'll try now. Of explanation. I have not such approach for this now.
Okay, it's not a problem. Okay. So you can try it. So you were trying kind of a brute force approach, right? What you said.
Yes,
So look, 2 to the power k is means 2 to the power 30 is already in, I guess, 10 to the power, I guess, 7 or something, or maybe greater. I don't remember perfectly. So doing this for n times, that is for k operations, will already give you a TLE. So we need to also look at the time constraint in the question. So means you need to understand that a brute may not work. It may if you do some optimization, but in general in this question, brute may not work. We need to see some observation. So we have means for k equal to 3, k equal to 3. Preetham, just tell me how many cells we will have with this formula.
we will have 9 cells.
Yeah, so we got our 9 cells, right? And we also have given A, and we have also B here, right? This is what the question said. Then the question says, for all the means empty cells in between A and B, have the middle one, okay, that is the index of this A and index of B, add them up and then do it half, that is the middle, and then have at this index the XOR of A plus B is the XOR of A and B, that is XOR sum of A and B, right? Then the question says that in step 2, between all the empty values, these for these cells, can you see the extreme extreme ones here? Extreme ones here are A, XOR B, and B itself, right? So this is the center. So it will be what? It will be A XOR B XOR B. It will be A. So I hope both of you know this property of A XOR A being 0. And also it is commutative, this XOR property. Okay, right. So I hope you know. So then we move to A XOR B into XOR of B, that is we get A. And again, for here, these two extremes, we do A into A XOR B. So what we get here? We get a B. So Preetham, tell me, what will be the value of this
Uh,
cell?
A's or B.
A XOR B, right? And for this,
It will be A.
right? And Alicia, tell me for this, what will be the XOR?
It will be B.
Right. And for this,
Again, A's or B.
right. So at the end, we got our sequence for 9 digits as A, then A XOR B, then B, then A, then A XOR B, then B. It's like repeating in three. So we are getting some hint that the pattern is repeating. And also as it's XOR, we already know that we'll always have something in, what do we say? It will be something like P times XOR of A and Q times XOR of B, right? Q times XOR of B. So it will be nothing different from that. And if uh, P and Q are odd, then we already know that it will be the final answer will be A or B, as all even XORs will cancel out. And if one of them is odd, then it will be A or B, right? And if both are means any one of them is like 0, then also the XOR will be 0. That is, both of them are odd. Then also the or even it will be odd. I guess you understand that we only have 4 possible cases: A XOR B, B, and 0. Right? What we have given in the question to return, you need to compute the following expression, that is x1 into y1. That we are it is asking us to return the summation of all set into unset bits. I hope you all know what is set and unset bit. Set bit is nothing; it's just 1, and unset bit is just 0. So right. So this is what count of set bits into unset bits for each number. So means only have 4 combinations possible. For A, the combination can be, for A the combination is what? For A, it's already given to us what A can be. So A is what? A is given in our sum. It will have a count of C1, and the C0 count will be n minus C1, right? This is X, this is Y. Right. So we have our count for A as xy. For B also we have C1 and Cn minus C1. So for B also have xy. And for A mod B, we check if in AB we don't have the same value, then we have the count of 1. So what I am meaning is, like, let's have this example. So what we had in our test case, we had A is 101, sorry, 010, and B as 110, right? So in this, for A, how many set bits are there and how many unset bits are there? Pritam or Alisha, anyone of you can answer.
Set bit is 1 and unset bit is 2.
Right. And in the second one,
Set bits are 2 and unset is 1.
right. And if you XOR them up, then what will be the answer? These two are unequal. So it will be 1. These two are equal, so it will be 0. And it will also be 0. Right. So it will be 1 into 2. For A XOR B. So we can naively calculate our these values, x and y values. Right. So we only need to understand how many A's are there in the whole array, how many B's are there in the whole array, and how many A XOR B are there in the whole array. I think you all got what I said for now, Pritam and Alisha.
Yes, we.
Okay, so let's check few things. Let us consider something like, let's have three elements, AI plus 1, and AI plus 2. Right, this is what the elements we got. So let us see that to get A of I plus 1, what is we have to do? A1 XOR of A2, sorry, AI plus 2. Right, look, this is what I'm meaning, that to get in, we have this, yeah, three values, I1 and I2 at these positions. So for V of I plus 1, that is A of I plus 1, we take XOR of V of I and V of I plus 2, right? Then if we let A of I be X and A of I plus 1 be Y, then what will be A of I plus 2? See, A of this XOR is, what do we say? It's replicative in itself. So we just, to get A of I plus 2, we do of XOR of A of I is take a XOR of A of 1 on both sides. So it's simply nothing but A of I plus 1 into XOR of A of I. Right. So XOR, V of I into 2 is XOR of this X and Y. So it will be X XOR Y. Right. Alisha and Pritam, I guess you all understood this is a very basic thing. So we can see it is repeating in a pair of 3. It will go like X, Y for starting at any I. So it will go like X, then Y, then X or Y. Then again it will be X, Y, then X or Y. Right. Give me a thumbs up if you are clear with the idea. Okay. So both of us know, means all of us know that the V of 0 means for I, that is V of 0 is equal to A. That is, if we take V of I is equal to A, then we only have A, means that is we have put X is equal to A. Then we have replaced here X with A. So it will be A into Y into A XOR Y. then it will be again A into A comma Y, then is or Y, right? So look, it is again repeating in a pattern of 3. Think of a case where 2 to the power k plus 1, what are the possible values it can have? Just tell me, both of you, that what are the possible values if I do a mod of 3 with it? What are the possible values it can have?
It can have three values,
Yeah, which values?
0, 1, and 2.
0, 1, and 2, right? Think, can we have a one value? If you think, then you will get to know that here, if we are having this 2 to the power k plus 1 elements, these many elements are here. We're taking a mod of 3. And it will never have a value of 1. This is because it's odd. You see, it's odd, and it is also odd. So this means if we are getting a mod value of 1, this means that this is even henceforth. So we can never get a value of 1. You can always get 0, or we can get 2. Okay. Clear, Pritam, Nalisha?
Could you explain again?
Okay. So let's see. 2 to the power k plus 1. Look, plus 1 is in subscript. It's not in superscript. Right. So this is an odd number. You are clear with this? Okay.
Yes.
So when we take the odd mod 3, what are the values we can get? Odd mod 3 will only have two values, 0.
Oh, got it.
Or
I got it. I got it.
yeah, got. I guess you got it. Right.
Yes.
So now we already see that there are three values in recurring. That is, we have these three values. Can you see A, then Y, then A, XOR Y? Okay. Then we have only two cases. If this mod 3, this is equal to what? If it is 0, then we can have a pair of 3 for all, right? So A of Y will be the last one. Understood why I'm saying this? We have 3, 3, 3, like this going on. Okay, then again at the end, there will be a sequence repeating like this. Preetham and Alisha, did you understand what I meant from this? That is, if we have a consecutive 3 length pair, that is, if the length is divisible by 3 and these are repeating in 3, these values are repeating in 3, then the last value of the array will be this. And we know the last value is B. Hence, to get Y, what do we do? To Y, we do A XOR B. Freedom, did you get it? Or
Not
Alisha?
actually.
Okay, so you understood this modulo concept of
Yes.
2 and 0. And
Yes. Yes.
Alisha, if you also have doubt, you can ask. So look, you already seen these return means repeat in a pattern of 3. Okay.
Okay.
You are clear with that? These are repeating in a pattern of 3. So if there are 2 to the power k plus 1 elements, there are these many elements, and it is a multiple of 3, that is remainder is 0, then this whole thing will always be completed. Are you getting it?
Yes,
What
yes.
did you get it now? Is there will always be a 3 repeating value like this. You will always go like this. This will be something like this. Are you able to understand what I'm saying? Like it will be a 3 value. Is the always ending value will be also a third repetition. If you aren't clear, you can ask me, or else we'll go on. Okay.
Yes, I got it.
Right. So what I meant was, look, here we have got 9 elements, right? And we are repeating in 1, 2, 3, 1, 2, 3, and 1, 2, 3. So the last element is B. We are getting an even distribution. So the last element we are getting here will be this A mod Y, sorry, A is or Y, and it will be equal to B, and which gives us Y is equal to A XOR B. I hope you are clear with this. This will be the last element, and this is also the last element we have. Okay. So we have got last element as A XOR Y, and it will be equal to B. And hence Y is equal to B XOR A, or you can say A XOR B. So the sequence is repeated like A XOR B, B, then again A XOR B, B, and this goes on till end. Did you get it? Alisha, did you understand the logic?
Yes, yes.
Yeah. So what we can see for the whole, if this is divisible by 3, this whole value is divisible by 3, then we are getting, if this is divisible by 3, out of each one, we are getting a A's or B, a B, right? So we need to only return X into Y. We have calculated our XY earlier. So we just return the sum of XY for each A, B, A, or B also. I hope this statement is very clear. You guys are already clear with it. Did you get it? For A mod B, this is the answer. Okay, right. So if and else if we see if the modulo is 2, we didn't get our 0 modulo, we got our 2 modulo. So what we can do, it will repeat in pair of not 3. So it's like this here. We are getting these values, means 3 value, and then there will be a remainder 2. You see, there will be a remainder 2. Pritam, now did you understand what I was saying? Like, if we always have odd integers, and then we have remainder as 2. We won't have remainder as 1 here. And if the remainder is 0, then this will be the last element. And if the remainder is 2, then this will be the last element. Got it? Y will be the last element. If Y is the last element, we already know the last element as B. So it will repeat like A, Y, oh, sorry, A, B, then A or B. Got it? What I meant from this. And it will keep on repeating till all the 3 pairs have ended. Like it will go on like this. And then there will be an extra A and extra B. Are you getting it? This thing ends at A or B. And again, there will be an extra A and then B. So the sequence will be, for the earlier one, it will be this, you have already seen. And from the next one, so the sequence will be A, B, A or B. Then again, it will be A, B, A or B. Then it will again be A, B, A or B. And at the last, it will be A, B. Only one A or B will be missing, right? So what will be our total sum? So our total sum can be this value what we have got here plus C1 and C2, as this will be less than a 3k multiple. So it's like a mathematical shortcut. So we could have also written instead of this, we could have written like 1. That is, we are taking all the 3 pairs. It's giving 2 modulo, right? So if you add 1, then it will be a constant sum. Okay. And then to the whole summation, we minus C3. Right. It would be the same as the earlier statement. And you already know what is C1, C2. C1 is the count of 1 in A, n minus count, that is bit set and unset bits multiple. And for this also, you know the same value. So the answer solution boils down to very simple. Like we are having our n and k and our a and b as S1 and S2. Then that is we are having our C1, C2, and C0. That is multiplied values of x and y. That is set and unset bits for each A, B, and C. Right. If S of I is 1, then it will be C1 plus plus. If S of 2 is 1, then it will be C2 plus plus. If S of 1 and S of 2 are equal, then the means unequal, then the set means XOR bit will be 1. So C of 3 plus plus. And then we calculate their multiplied values of set bit into unset bit. And then we check. Our main solution only is this part. If one right shift k, that is 2 to the power k plus 1, is a multiple of 3, we see out this sum, right? And if it's not a multiple of 3, that is, it's a multiple of 2 simply, then we see out this sum, right? So the solution ends here, and this is only what was left for the question. If you guys have any doubt, you can still ask me. And if not, then we will end the PCD session. You can ask me any doubt if you still have. And I will share this PDF blocks with you. So you can also refer to it later on. First years, if you don't have any more doubts, you can leave the meet.